Hello everybody, and welcome to the 8.1 Notes Part 2, where I'm going to start by doing a quick review of all the polynomial classification vocabulary, and then I'm going to go into adding and subtracting polynomials, and that is also what your homework is about tonight as well. So, as a brief review, remember that if you want to classify a polynomial by degree, that means, or this represents, the highest exponent that you see on a variable. So if you see something that is x to the 0th, that's a constant polynomial. If you see x to the 1st, it's linear. X to the 2nd is quadratic. X to the 3rd is cubic. X to the 4th is quartic. X to the 5th is quintic. And then after this, mathematicians got lazy, and x to the 6th and x to the 7th and all the way up would be a 6th degree, 7th degree, and so on. You also could classify a polynomial based on the number of terms. And you also might recall that a term is a combination of letters and numbers, all separated by a plus or minus sign. So this would be an example of a polynomial, specifically a polynomial with 1, 2, 3 terms. So this specific case would be a trinomial. However, if you had a polynomial with 2 terms, that would be a binomial. 1 term is monomial, and any polynomial that has 4 or more terms is called a polynomial no matter what. So to do some specific examples, what I'd like to do is classify the following polynomials, which I'll make up here, by degree and number of terms based on the last slide. And if the polynomial is not in standard form, we would like to put it in that first. So here's a first example. 2x to the 4th minus 7x to the 5th plus 3x. So first, this is not in standard form. And what standard form means is your highest power or highest exponent down to the lowest one possible. So my answer here in standard form would be negative 7x to the 5th first, because that's the highest power, and then positive 2x to the 4th, and then positive 3. So this would be your answer in standard form. And if you were going to continue and name this polynomial based on the degree, the highest degree that I see is 5, and the vocabulary word that goes with that is a quintic type of polynomial. If I continued with number of terms, we have 1, 2, 3 terms all separated by a plus or minus. So because I have 3 terms, this is called a trinomial. So in the end, if I asked you to classify this, you would call it a quintic trinomial. Another example. What if I had 2x minus 10x squared? Well, first, if I put my answer in standard form, these two would have to switch places. The negative 10x to the 2nd would come first, and then the positive 2x, or 2x to the 1st technically, would be my standard form because my powers go from highest to lowest. If I am worried about my degree, the degree of my polynomial is the highest exponent that I see, which is 2, which makes this quadratic. The number of terms also happens to be 2 in this instance because I have 2 terms separated by a plus or minus. So this would be a binomial. So if I asked you again what is the best name for this polynomial, you would call it a quadratic binomial. And usually the name versus degree goes first and the number of terms goes second. So based on that, I would like to do a couple for you to try here, 3 and 4. So if you could please write down the polynomial negative 3x and the polynomial 5 minus 2x squared plus 4x to the 3rd minus 1. What I'd like you to do is decide if it's in standard form and determine the name based on degree and number of terms. So please pause now to try them by yourself. All right, guys, so I'm back. Please check your answers with mine. Negative 3x, I said this is really x to the first. So I said the degree was 1, which meant linear. And the number of terms was also just 1, because there's no plus or minus sign separating. So I said this was a monomial. So my answer was a linear monomial for number 3. And number 4, I noticed that I could combine the 5 minus 1 to be 4. So my standard form was 4x to the third first minus 2x squared plus 4. So my highest degree was 3, so I said cubic. And the number of terms ended up being 3 because I could combine these together. So I had a cubic trinomial as my answer. Now, if I had changed this problem just a little bit, and let's say that I had an x on that 1, my standard form would look like this instead. I would have, instead of the plus 4, I would have minus 1x plus 5 if I had had this originally. And then my answer would still be cubic, but if there were 1, 2, 3, 4 terms, this would be polynomial instead of trinomial. So you don't need to change this problem, but I thought I'd point it out to you just in case for more vocabulary practice. But for now, just for the sake of everyone knows what the final answer is, this was a plus 4 to match with this. The main part of the video here that I want to get to is adding or subtracting polynomials. So we talked about the vocabulary, but now we would like to add or subtract or really combine like terms. And in order to combine like terms, both your base and the exponent must be the same. And here is what I mean by that. If we look at number 1, the reason the parentheses exist is so that we could use the previous terminology. So because this is 2 terms, what I'm really doing is adding a binomial plus a trinomial. Now, when I'm adding, what I'm really distributing for both of these, there's technically a 1 in front of this parenthesis and a positive 1 in front of that parenthesis. If I distribute the 1, it doesn't change the signs or really anything about these numbers. So what I can do is just drop the parentheses as long as I recognize that I am adding a binomial plus a trinomial. Now I just want to look for the terms that are like. Look for the base and the exponent to be the same. This m squared and this m squared can be combined. I have 2m squared plus 1m squared, so I'd have 3m squared. If I have a positive 6m and a negative 5m, that would be a positive 1m. And then finally, the 7 does not have anything to combine with, so that would just go on the end. And notice that my final answer is in standard form, that I went from my highest power down to my lowest, and that I cannot combine anything else together because they're not like terms. Number 2, what I'm doing is I'm taking a trinomial and I am subtracting another trinomial because both of them have 3 terms. Now, this example, because I'm subtracting this parenthesis, what we're really doing is we are distributing a negative 1. So that negative has to distribute to everything in this parenthesis, but this parenthesis has a positive 1 being distributed, so nothing changes sign here. So what I'm going to do is recopy the first parenthesis, or the first 3 terms, but then I'm going to change the signs on the second 3. So negative 7a squared plus 7a minus 5. And now, like number 1, I'm going to combine like terms. 5a squared can combine with negative 7a squared, so that would be negative 2a squared. Positive 6a combines with positive 7a, so that's positive 13a. And then positive 2 and negative 5 would be a negative 3. So this would be my answer in standard form. So what I think would be a good idea at this point is I would like for you to try numbers 3 and 4 on your own. So if you could pause the video after I'm done talking, I will have the work for you when you get back. So please pause the video now. All right, guys, here's my work for numbers 3 and 4. Number 3, I did a binomial minus another binomial. So I made sure to distribute the negative to both terms. And when I did that, it became negative 5x and negative 2x squared. I combined the x squareds together and got negative 3x squared. Combined the x's and got negative 2x. Number 4, I was adding a trinomial plus another trinomial. When I distributed, I was distributing a positive 1, which did not change any of the signs, so I just combined like terms. Got the 2w squareds to be 6w squared, because there's really a 1 there. Negative 4w and negative 3w is negative 7w. Negative 1 and negative 5 is negative 6. So one more, and then I'm going to have you practice a few more. Here, I'm taking a trinomial, and then I am subtracting a binomial. And the negative would need to distribute, so I'd have 4k squared plus 8k plus 2 minus 2k minus 3. And then the 4k squared does not combine with anything, but then the 8k and negative 2k would be 6k. And then finally, the 2 minus 3 would get me negative 1. So here's my answer in standard form. What I think would be good to try is for you to pause, and I'm going to write down 2 examples that would be good to try on your own. So number 6, I would like you to write this binomial minus this trinomial and then I would also like you to write this trinomial plus this binomial. So once you have these copied down, if you could please pause and try these again on your own. So please pause now. All right, guys, so to check back in, number 6, my final answer was x squared or 1x squared minus 9x minus 10, because I made sure to distribute the negative to every term here. So it became negative 3x squared, positive 3x because the negative times negative, and then a negative 10. I then combined the 2x squareds to get 1, then 2 x's to be negative 9x, and the negative 10 just came down for the ride. My answer was in standard form. Number 7, I added a trinomial to a binomial. When I distributed the positive 1, again, I did not change signs, but the reason I had this problem for you to try is I'm sure some of you noticed that the only things that you could combine were the x squareds. There was nothing else that was a like term. So your final answer was truly a 4-term polynomial, 10x to the 4th minus 5x squared plus 5x minus 3. All right. Last problem in these notes here has to do with a geometry connection. And it says the measures of 2 sides of a triangle are given. If P is the perimeter, and perimeter represents your distance all the way around your triangle, if this is your perimeter, we want to find the measure of this third unknown side. So what we already do know is that perimeter represents side 1 plus side 2 plus side 3 equals the perimeter. So we already know what side 1 and side 2 are. So this would be 3x plus 4y plus 5x minus y plus I don't know equals the 10x plus 5y. So if we wanted to figure out what this unknown was, what we'd have to do is subtract both of these over to the other side. So if I combined these, I would get 8x plus 3y over here plus I don't know equals 10x plus 5y. So if I subtracted the 8x to the other side, I would get 2x, and if I subtracted 3y to the other side, I would get 2y. So my unknown side is 2x plus 2y. So that's a little bit of a geometry connection. So I thought, why not? Because it's a polynomial, introduce it now. So last but not least, what I wanted to show you here was the answers to that homework worksheet that's attached. So feel free to keep this screen on and please try your worksheet now, and you can check your answers here. Thanks.